In this video, I'll be going through one of the examples that you're asked to complete in the Lewis Structures and Models Lab so that you can have a good idea about my expectations and how you'll find each one of the components. So the lab is written where you're going to be looking for, it's actually 6 things, but there's 5 of them right here. So I don't want to put boxes. Let me number them. You're going to look for the Lewis structure, the electron pair geometry, the molecular geometry, a VSEPR drawing, a bond angle, and then you will also have a picture of a model that you're going to create. Now, the model is the only thing that you will have to do on campus because you'll need one of the model kits to complete it. Now, how the lab is written, which is where my mind started first, is that it goes through and it describes how you do the Lewis structure for all of them. And then it goes through the geometries and then the VSEPR drawing. So one way to approach completing the lab is to do each one of these sections individually. But what I would prefer to do, and it's easier for me to evaluate what you're doing, is if you do all 6 of them for one substance together. And that's what I'm going to show you now, is how it might look if you did all 6 of the asked things at once. Well, not at once, but do one substance at a time, I guess is what I'm trying to communicate. So I am going to pick the CO3 2 negative to show you how to do it. So you're going to have a total of 6 species that you're going to do all of these 6 things for. And I do want you to include CO3 2 negative as a part of your lab. Now, you can create a table like it's shown here in the lab manual, or you can just on one page or a half a page in an organized fashion write all of the 6. You're going to write 5 things and then you need a picture of the model. So let's go ahead and we'll start. So I'm going to do the Lewis structure first, and so if I were doing this as a part of my lab, you want to be sure that you write the formula for the species you are doing on that page so that it's clear to me what you're doing. So if you remember Lewis structures, which we've covered in class, you want to write how you think they're oriented. I think carbon is in the middle and the oxygens are on the outside. And you also want to add up the valence electrons. I'm not going over in detail how to do each of these steps. I also have videos on Lewis structures, and we've covered it in class. So let's see, there's 1 carbon in the formula, and from the periodic table, I know it has 4 valence electrons, so the carbon brings 4. Oxygen, there's 3 oxygens in the formula. They each have 6 valence electrons, so that would be 18. And if I add those 2 together, I have 22 electrons. Now, this is a polyatomic ion, and if you look right there, it has a 2 negative charge. And so if you recall, from the chapter, that when you have a negative charge, what's happened is that electrons have been gained. So when you add electrons to something, they have a negative charge. So a 2 negative means 2 electrons have been added to the CO3. So when we're calculating up the valence electrons, we have to add 2 electrons to our total. So those 2 electrons there are added because of the 2 negative charge. Now, the other species that we have here, if you look at all of the other ones, none of the rest of them have a charge, so you won't add anything extra when you're counting the valence electrons. Okay, so after we get the valence electrons, this is the number that I say is the magic number. I just make up kind of a entertaining language for myself. This is a magic number. We have to use 24 electrons in our Lewis structure. So how you do it is first just start by drawing single bonds connecting the atoms to the center. And that would use 2, for each bond there's 2. So 2, 4, 6 electrons, counting each bond, just thinking 2, 4, 6. So that means I've used 6 whoops, I didn't change my pen, sorry. I use 6 electrons, so then I have 18 electrons remaining. And you place those 18 electrons around the periphery, which means the outside atoms, making so they all have 8, unless you have a hydrogen, which can only have a single bond. So that means I'm going to go 2, the pen doesn't work very well sometimes, 4, 6, around that. So that would give it 8. Let me count it just so you see. 2, 4, 6, 8. And then I'm going to do the same to the other oxygens. Whoops, I forgot to change my pen back. I'm going to try to make this pen a little thicker to make my dots easier. There we go. I'll fix these. Okay, so now we have added, I think, 24 electrons, because I just added 18. Let's count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right, so we have added 24 electrons total. So that means we have no electrons from here remaining. Now, before I finish this, you need to look at this central atom and notice that carbon only has 2, 4, 6. I can't add any extra electrons because I've used all of the electrons from my magic number of 24. And so what this indicates is that I need to take one of the the lone pairs, like here, and move it and make it a shared pair. Now, I could take any of them from any of the oxygens and move them to the bond closest to them. I'm going to choose the one I just marked. So I'm going to erase this one here. Let me fix my oxygen. And then draw a double bond. So now I still have only used 24 electrons, so that's right. And now if I look, each atom has 8 electrons around it. Carbon has 2, 4, 6, 8 because of the double bond. The 2 oxygens with single bonds have 2, 4, 6, 8 and 2, 4, 6, 8. And then this oxygen on the left has 2, 4, 6, 8. Get rid of all the yellow. All right, so this right here is the Lewis structure. For atoms with charge, it's very common to see a bracket with the charge on the outside. See right there? Because what it indicates to someone looking at your Lewis structure is that you have added 2 electrons. All right, so that would be the Lewis structure. This would be what was number 1. And then we have number 2 and number 3. And for both of these, we have to use the shape sheet, which I have on the next slide. There is a copy in the lab to find it. I also may have given you one already, but you're going to use your shape sheet for this. Now, in the shape sheet, we have to look at our central atom. I'm going to use a different color here because this isn't really part of the VSEPR. I have to look at the carbon for the shape. We're using something called the VSEPR model, which stands for valence shell electron pair repulsion theory. And in very simple terms, it says that the electrons that are around that central atom are all negative charge. So like charges repel, and they will push away from each other as far as possible, and that's what will create the shape. So when we're trying to figure out the shape using the VSEPR theory, that's our shape sheet, we have to look at the center and we count how many atoms are attached or bonded to it. And I see 1, 2, 3. So there's 3 atoms bonded to the carbon. And then I look at the carbon and I look for lone pairs. Now, lone pairs are the dots, like these over here that I'm circling. There are no dots on carbon, and for the shape, you only look at the central atom. So for carbon, there's 0 lone pairs. So this right here is the information that I need to figure out the electronic and molecular geometry on the shape sheet. So I have the shape sheet on the next slide. And I'm just going to write up here. We said there were 3 atoms and 0 lone pairs. So if you look here, this first column is the electronic geometry. This column here is the molecular geometry, which is also called the shape. And then here are the number of atoms and the number of lone pairs. Now this might be too small for you to see clearly on the video, but I hope that you have this actual document in front of you from one that you've received in class. So what you do is we need 3 atoms. So you go down, like I see 3 atoms here and 3 atoms here, but it has to be with 0 lone pairs. And so if you look right there, here is a 3 and a 0. So 3 and the 0, the electronic geometry is trigonal planar, and the molecular geometry is trigonal planar bent. So that's how we're going to find our answer. So on the previous slide, we would write trigonal planar and then trigonal planar bent. Now, I also have videos that go over more examples of shape that you can find in Canvas. So if you need another example, you're not quite sure, watch those videos. I'm assuming at this lab that you have a basic understanding of some of these things, because we're supposed to be practicing. All right, so we said trigonal planar, and on the other previous page, I wrote my Lewis structure like this. I'm just redrawing it. So a VSEPR drawing shows shape. And so a good example is whoops, I messed this up. Look at me. Did I write it wrong? Yes, I even totally wrote it wrong. Oh my goodness. Okay. I'm not going to start this whole video over. I circled this one. I was thinking, it's okay. I have to back up for you now because of the mistake I made. So this part is right, getting to 3 and 0. Here, this is 3. I don't know why I even circled that one. You're probably like, that's a 2. There's a 3 here and a 0 there. So it is trigonal planar, but it's just also trigonal planar for the molecular shape. And I apologize. I was thinking through, I don't know what I was thinking. I just circled it. This one down here is 3 and 1, so it can't be that one. I just wasn't paying attention, and it is very small on my screen. So I apologize for that little bit of confusion. It is what we did here is right. There's 3 atoms and 0 lone pairs, but on the chart there's 3 atoms, which is trigonal planar, and then 0 lone pairs, which is also trigonal planar. So what would change is this would be trigonal planar. I'm sorry if you were confused for a moment there. I caught myself once I redrew the Lewis structure. Okay, so I wrote that one wrong, but what I was going to say, and this is what it caught me, the Vesper drawing shows shape, so you're going to try to draw it like this, so it shows shape. So I actually will accept several things here. Like if I wanted to show the shape, it looks like this. So I'll accept you just redrawing the Lewis structure in a shape so it has the angles. Or Vesper drawings don't have to have the lone pairs on the outside, so you could also just draw it with the oxygens without the lone pairs on the outside because Vesper is showing shape. Or you can even just draw it as symbols. So if you want to make like a triangle as the middle and then make little circles, they don't even really have to show the bonds. So you could do it that way as well. But you want it to look similar to what is the shape that you indicated in your shape sheet, and for it to have shape. Okay. So that, if we look back, that's number. So now we've done, I'm going to go all the way to the front slide. We've done, this is the Lewis structure. I'll just write it in here. You don't have to draw it as a table. You could literally just make one page with everything on it. So that's what Lewis structure. For this example, this is a 2 negative. This is trigonal planar. We use the shape sheet to figure that out. And this is trigonal planar. We use the shape sheet and how many atoms and lone pairs. And now 4 is the Vesper drawing. So I like to draw it with the elements there. So I probably would, but I don't care. Again, Vesper drawings just show shape. And then now is bond angles. And to find the bond angles, you're going to use a simulator. Now, what you're going to do to get the shape simulator, go into Canvas and in the module, find lab handouts. Here's the lab itself. Here's the shape sheet. And then here is the simulator. So you're going to push this. I did it even on my phone. It requires me to open it up on a browser, but it just did it automatically. And once you do, you'll go in and you will see something like this. So this is the first thing you're going to see. Looks like this. And so then you're going to click in right here. So push that, and then you're going to come in here. Now, I had to add, I can't make it go live on this video, but what you can do, this is all about the shape in the middle, and so you can add whatever kind of bonds you have. Like, it doesn't care what kind of atoms, like there's single bonds, double bonds, or triple bonds. And for this particular example, I have 2 single bonds added, like there's a single bond and there's a single bond, and then here's a double bond. And if you want to get rid of it, you just hit the X's that are right there as you change between things. And then if you have a lone pair, which some of yours will, you click on that and it will add a lone pair to the middle. Now notice there's no lone pairs on the outside. This is shape. So all it matters is about the shape. It only cares about the middle. You click the box right here and it will pop up these bond angles, which these are 120.0 degrees. That is, and they're all the same. You will be able to see it. It's larger than this when you look at it. And then if you want to check your electronic and molecular geometry, if you click those, you can double check if you got the geometries right. It will tell you. So I need bond angles. I also want you to see, if you look at this whole thing, it looks like what we were trying to draw, like that. So your VSEPR should match or look similar in shape to what this model is. So then going back, so the bond angles for all of these are 120 degrees. If you want to, and this is totally up to you, if you have your VSEPR drawing, you can, instead of making it as a column, you could just do like they do and draw a little arrow with 120 degrees. Since they're all the same, you don't have to draw them all around. But if you like that, you could draw them like they have it in the model simulator. All right, so then we have one last thing. So now if you look back, let's look back. We've done the Lewis structure. We used the shape sheet. That's what these two things use. They use the shape sheet. Well, actually, all three of these can use the shape sheet. And then we use the simulator for this. And so now all we have is number 6, the model. So this is number 1, 2, and 3. This is number 4 is the VSEPR. 5 is the bond angle. And then finally, that's the simulator we looked at. This is the model. And you'll have to ask for the shape kits from me. And so what you're going to do, here is our Lewis structure. And so the models, if you look, there are 3 areas sticking out, 1, 2, 3. So I found a center atom that has 3 holes in it because they have holes. Then I use this to represent the bonds, and notice it doesn't matter if it's double or triple, sometimes or single. Sometimes students will use a different color. There's a tan colored bond. Sometimes they'll use that for the bonds there. And then I used, I don't know why I used 3 different colors. Usually I would have used all the same. I was just putting it together. I'm going to color it in, so there we go. So they're all green, so they look like oxygen. And then you're